Okay, this is Geometry Unit 1. It's called Geometric Foundations and Relationships. And this is Lesson 1. The lesson is called Points, Lines, and Planes. Okay. Now, I love geometry. I love teaching geometry. It's one of my favorite classes to teach. This first lesson, though, this isn't the most interesting lesson in the world, but it's really important to understand this lesson for the future. Okay? You're going to use this lesson a lot throughout the year. All right, so I started by saying in geometry, some words such as point, line, and plane are undefined. So they don't have definitions, but we do have descriptions to describe them. The first one, you can think of a point as a location. You can think of a point as a location. Okay? Points have no size. And in diagrams, they are represented by a small dot. Okay, and when you name points, you name them with a capital letter. It is named by a capital letter. All right, this next description is going to be a line. A line is a series of points that extends in two opposite directions without ends. That's a line. And you'll see you have a line drawn over here. W is a point, X is a point, and Y is a point. Now back to lines. There are two ways to name a line. The first way is to name it with 2 points on the line. Okay, 2 points on the line. For example, let's do X and Y. Those are 2 points. They're on the line. And you're going to use this symbol above it. Okay? Notice how it has arrows on each end. Now, it doesn't matter if you put X first or Y first. So if I put YX, it's the same exact thing. But again, the key word is it's only 2 points. So you only use 2 points. Don't put WXY. The other way you can name a line is you can name it with a single lowercase letter. It'll usually be labeled off to the side like that. So you can name it with a single lowercase letter, such as M. Okay, and one more definition kind of on this page. Points that lie on the same line, those are called collinear points. Like your coworkers or people that you work with, collinear points are points that are on the same line. Okay, moving on to the next page. Example 1, refer to the diagram to the right. Are points E, F, and C collinear? Are points E, F, and C collinear? That means, are they on the same line? So E is right there. If it's at an intersection, sometimes it doesn't have a dot. Okay, so that's point E, that's point F, and that's point C, and you see they are on the same line, so yes, they are collinear. And it says name the line that they're on, so I'm going to say yes. They're on line, I'm just going to name it with that letter right there. They're on line M. Okay, part B, are points E, D, and F collinear? E, D, and F, are they collinear? No, they are not on the same line. Okay, moving on. One more description. We already did points and lines. Now this one's going to be plane. P-L-A-N-E. A plane is a flat surface that has no thickness. Okay? It contains many lines and extends without end in the directions of all its lines. This is called a plane. Planes are usually represented like this in diagrams, okay? Now, this one is a little harder to understand, but one way you may have heard of a plane in the past is if you watch football, a lot of times a player will come close to getting a touchdown and he'll reach the ball out to try to score. He'll try to get past the goal line. And you'll always hear the announcer say, did the ball break the plane of the goal line? So that's an example of a plane. Now there are two ways to name planes, okay? The first way is with at least 3 non-collinear points. So they cannot be in the same line. So for example, you can name it like this. You have to write out the word plane, P-L-A-N-E, 3 points that are not collinear. This is not a point, by the way. That's not a point. There's no dot next to it. So these are your 3 points. You have to make sure the points are not collinear. You have to make sure the points are not on the same line. They have to be non-collinear. So if B was down here, for example, and A, B, and C were all on the same line, you cannot name a plane like that. 3 points have to be non-collinear. The other way you can name it is with a single letter like that. Usually it's off in the corner. It's not a point, though. It's a single letter. So, for example, you can name it plane M. This last definition, points and lines in the same plane, those are called coplanar. Okay, coplanar. Okay, halfway done. 2 more pages. Example 2. Name the plane represented by the front of the cube. So that's this plane right here. You're going to use at least 3 points, and they cannot be in the same line. So one way to name that plane is you could call it plane AEF. Or you could call it plane ABE, for example. Plane ABE. Another way is you could say plane ABF. And I'll put down etc. I'll stop there. Okay, this next definition is called a postulate or an axiom. You can use either word. They mean the same. A postulate or an axiom is an accepted statement of fact. It's something that's true, but it's never been proven, but it's true, and everybody accepts it as being true. So I'm going to go through 4 postulates or axioms with you right now. The first 2 are pretty straightforward. The second 2 are a little tricky. Okay, so this first one I'm going to talk to you about. I'll write down postulate. Through any 2 points, there is exactly 1 line. Through any 2 points, there is exactly 1 line. So I'm going to draw 2 points. I'll use A and B. Those are my 2 points. Through any 2 points, there is exactly 1 line. So that means I can draw a line through those 2 points. Only 1 line. That's the only possible line I could draw that would go through those 2 points. Here's another postulate. If 2 distinct lines intersect, distinct means 2 lines that are not the same. Okay, so if 2 lines are not the same, if 2 distinct lines intersect, then they intersect in exactly 1 point. So I'm going to draw two lines. They're not going to be the same line. I'm going to draw two different lines. And you'll see that they intersect, but they only intersect at one location, and it's a point. So let's just label this. These two lines intersect at point C, I'll call it. Okay, now two more postulates. These are a little more difficult to visualize. I'm going to go down here. If two planes intersect, then they intersect in exactly one line. So if two planes intersect, because they don't have to intersect, the planes could be parallel to each other, which we'll talk about in the next lesson. But if two planes do intersect, then they always intersect at a line. So I'm going to try to draw a diagram. This is really hard to draw and visualize, but let's say that's a plane. And let's say this is a plane. Planes extend indefinitely. So they intersect right here, which is a line because it's going to extend forever in each direction. Okay. And this last postulate, which I'm not going to draw a diagram for, but I'm just going to tell you. Through any three non-collinear points, there is exactly one plane. We're not going to do much with planes throughout the year, which is good. Okay, let's try the last page now. This should go pretty quick. This last page is pretty straightforward. What is the intersection of plane FGH and plane BCF? Where do those two planes intersect? Well, if they do intersect, they have to intersect at a line. We just went over that in the last page. Let's color in those two planes. Plane FGH is this top plane right here. Okay. And plane BCF is this plane right here on the right. By coloring it in, hopefully you can see where they intersect on the diagram. It's right here. And remember, planes extend indefinitely. So this is going to extend indefinitely. So it's actually a line. And the answer is a line FG. Example 4, shade the plane that contains points A, B, and C. Okay, so maybe you might want to pause the video and think about it ahead of time. And if you're taking your own notes, maybe try it ahead of time. But the plane that contains points A, B, and C is this plane down here at the bottom. So that's the answer for that one. And the last example, shade the plane that contains points C, E, and H. So it's not actually a side, but it's this diagonal plane right here. Let me just draw it in really quick. For any 3 points, you can draw a plane. So this is the plane that contains those points, C, E, and H, it said in the question. And that is lesson 1, points, lines, and planes.